Hello and welcome to our ongoing series of tutorials for the AEPS System Planning tool. In this tutorial, we're going to take a look at an overview of the various System Planning tool capabilities. We'll begin at the main window that appears when the tool first starts up. There are four major areas. The first is a menu bar that occurs across the top. There's the main model window itself. There's a site information area, and then there's a component palette along the left side. We'll be using all of these areas during this tutorial. We'll begin with the site information area that's used to configure the site-specific data describing the energy potential for the location of your alternative energy system. The System Planning tool comes with a complete database of solar and wind data for various monitoring stations across the United States. You can select the closest monitoring station to your alternative energy system site. To see the distance for your site from an available monitoring station, enter the latitude and longitude values for your site if you know them. We next move to the System Components area. This area contains widgets which represent the various components of your alternative energy system model. There are 5 basic types of components. There are site components, generation components, core components, storage components, and load components. If you've edited the site information that we discussed previously for your alternative energy system, the related site components, in this case the sun and wind, will contain the site data available from the selected monitoring station. You can edit the default site data directly in the applicable site component if you have more accurate information for your site. The generation components represent the various alternative energy technologies available to use in your model, such as solar arrays, wind generators, and hydro generators. For this example, we'll use a solar array and a wind generator to match our sun and wind energy sources available at our site. We'll also use a core component to connect our energy generation components to our energy load components. A core component is a convenient way to hide the details of the various electrical components needed in the final alternative energy system to be installed. And finally, we'll add a couple of load components to represent the energy consumers in our model. Once we have added the needed components to our system model, we connect the components together in order to represent how we would like energy to flow in our system. The green highlighting of a pure component indicates that it is a valid component to connect to. When all of the component connections have been made, the user can review and update the default configuration of components in the model. Each component type has a unique list of configurable characteristics that allows the user to tailor the component's behavior and representation in the model as desired. At any point during model design and construction, the model can be saved to a local database. To save the current model, go to the menu bar and under File, select Save Model. Enter a name for your model and click OK. Now conversely, you can open a model that has been saved previously. Again, go to the menu bar under File and select Open Model. A list of the saved models will be presented to select from. In this case, we've opened one of the sample models that is available as part of the System Planning tool download. We now move into the more interesting areas of the System Planning tool now that we have a completed model. One thing we can do is to verify that the model that we've created has been connected together correctly. This is a necessary step prior to running a simulation with our model to ensure that energy flows through the system as we expect. After verifying our model, we now get to the really interesting area of running a simulation. One of the powerful capabilities of the System Planning tool is, after creating a model, you can evaluate its performance in a simulation. A simulation can run anywhere from a month up to a full year. During the simulation run, all data associated with energy generation, consumption, and storage is accumulated and made available for later analysis, as we'll see. When running a simulation, a summary window is displayed showing the progression of time in the simulation, as well as the overall performance of your system model. The performance summary includes the amount of energy in kilowatt hours generated by your system model and consumed by the model. The summary includes a calculation of how much energy was generated but not consumed, listed in the overproduced section, or how much of an energy shortfall there was, listed in the underproduced section. If your system model included a tie to the electrical grid, the totals of what was pulled from and pushed to the electrical grid is provided. Lastly, if your system model includes battery storage, a summary of battery status is provided. Now, while this performance summary data is interesting and provided in real time as the simulation is running, the really interesting data is available under Details. Here we see a variety of detailed data on the performance of the system model is available for review and analysis. Much of the data is available in tabular and graphical formats. There are three main areas of detailed system data. The first is a summary of the behavior of each component in your system model over the timeline of the simulation. There are 4 subsections in this area that contain component details in tabular form, component details in graphical form, a chart depicting how energy generation is allocated across the generation components, and a chart depicting how energy is consumed across the various load components. The next main area is a graphical representation of the behavior of each type of component, including generation, load, and storage components, over the timeline of the simulation. This area has 3 subsections that provide the detailed component behavior over time. There's a subsection for generation details, one for load details, and one for storage details. Each subsection provides the option of viewing the data in the context of a day increment or all the way down to an hour increment. The last main area is a graphical representation of the behavior of the system as a whole over the timeline of the simulation. Both the component details that we saw previously and the system details in this area can be viewed for any given month of the simulation timeline. Within a given month, the graphical data results can be viewed at the increment of a single day or even down to a single hour of the simulation timeline as we saw previously. An in-depth description of each of these charts is provided in the user's guide. At this point, we're almost through our system planning tool overview, but there's one more important capability to tell you about. If we go back to the main menu bar, we can select Perform Cost Analysis. This capability allows you to identify various component and other system costs in order to generate a full cost estimate associated with your system model. There are 5 major areas to discuss under Perform Cost Analysis. The first area contains subsections to capture material costs for each type of energy generation technology you've identified in your model. For our example model, we have a solar array, a wind generator, and a hydro generator. The next area is used to capture the various installation costs associated with your alternative energy system. The next area is used to capture costs associated with being connected to the grid if your model is used for a grid tie system. There are 3 subsections in this area, including a section for capturing grid connection fees. Another section is used for capturing the cost of buying energy from the grid. This section supports numerous utility rate plans, so please make sure you know what rate plans are supported by your utility company, if applicable. The third section is used to capture the credits associated with selling surplus energy back to your utility company. Again, many different sell-back rate plans are supported by the tool, so please research what sell-back rate plans are supported by your utility company. The next major area of cost analysis is used to capture costs associated with rebates and tax credits. The System Planning tool supports one-time rebates and multi-year rebates. The last major area of cost analysis capability allows the tool to begin calculating the cost of your system based on the system model that you created, the performance of the model during a simulation, and any material and installation costs that you provided. The results of the cost calculation are divided into 4 subsections. One section provides a system cost overview that includes an estimate of a break-even point for your alternative energy investment. Another section provides cost details associated with the alternative energy components specified in your model. The third section summarizes all of the alternative energy system material costs. And the fourth section summarizes all of the alternative energy system installation costs. At this point, we have briefly discussed each of the major capabilities and features of the system planning tool, including model generation, running a simulation, and performing a cost analysis. Each of these topics are expanded upon in detail in the System Planning User's Guide. This concludes our overview tutorial. Thanks again for joining us and have a great day.